Yes, it is clear.
Yes. So last time I don't know whether we were able to generate stories, but this is what I have in the drawing.
When do you go in order to get the 3-dimension figure?
So for the 3D, let me close
Yeah.
it. This is in 2D. So to see your drawing in 3D, you go to views.
Okay.
And then you come here, 3D physical model.
Sorry?
3D physical model.
View 3D physical model.
Yeah. So you click there.
Yes.
And it will open another tab for the 3D now.
Okay.
Yes. And sometimes you maybe want to see all of them at once. What you see, you select the window from here. So you can either pick tile horizontal, you will see the plan on top and the 3D below. Then you can go tile vertical. This means they arrange them in vertical order. You can also go the smart way. If there are more than 3 floors that you want to see. Maybe you want to see the first floor, second floor, and all that. Yes. But I don't want to open many windows because they might drag my work. So I'm going to close. Yeah. And then I do 3D physical model. Then let's wait for it. There it is. Let me reset. So I have my floor, my 3D here, and then my floor plan here at the back. So last time we were able to model the columns, and I hope you have been able to do that throughout the entire week. From columns, we modeled our beams. From our beams, we modeled our slabs. Yes. And we were able to load. I don't know whether you remember how we were loading our beams.
Did you went ahead on loading?
Good. If we did not, then that is where we're going to start today. So to load our beams, I said first of all, last time I said you move from left to right. So we looked at building set out. We set out all other properties of our building. And then we went to modeling. This modeling is what we use to generate our axis or our grid lines. Then we use that to model column. And then we said that a wall is modeled just like a column. But because it is long, we model it like a beam now. And then we looked at slab, and you have the slab right here. So today we are going to now proceed to loading. Now, once you get to loading, you can click on loading, and then whatever appears on this toolbox here, you click on partition wall loads. This is when we want to load our beams. In partition wall loads, you have a number of walls here. You can pick one, but assuming we're using these 100 brick wall Malaysia, we can still change all the properties here. So I can come and I double click here. I can edit this to say maybe 200 mm thick Darugo stone or block. Sorry, 200 mm thick Darugo block. And then layer name, you come, because those blocks are dense in nature, you pick dense blocks. If they are bricks, you can pick these bricks here. If the blocks are light, depending on how the blocks are, you can pick that, but we're going to use dense blocks. And then the unit weight of dense blocks is 20. Look at what happens when I pick medium blocks, it changes to 15. So whatever I pick has an impact on the unit weight of that wall. So they are dense blocks, the unit weight is 20 kilonewtons per meter cubic. The layer thickness of our walls normally is designed as 200 mm thick walls. These will have a load value of 4 kilonewtons per meter squared. So having done that, I can say okay, and I will have saved the loading that I want to appear on my beam. So let me go back to the plan. Since this is the plan, I can select any beam. assuming I have selected that beam, then I right click, I go to edit wall load, edit wall load. And then it brings me to this dialog box here. In this dialog box, I'm able to select the wall I'm designing for. I'm able to say 200 mm thick Ndarugo block. And then I input the wall height. You realize that this dead load is 0 because the wall height is 0. So assuming I have 3 meter high wall, so I can do 3. But remember, we have beams in our structure. So I want us to know something. Let's cancel that first. Let's go to our stories, building set out stories, edit story. Here we had set the ground floor level to be 4600 millimeters high. But remember, the beams we are designing are from the first floor. So the floor to floor level will be 3000 millimeter high. Yes. So I'm going to have beams. If the ground floor level was to be suspended, then I would have considered this 4600 to be my first floor to floor height. But this ground floor is not suspended. We are just going to use a 142 DRC mesh to fix it. The ground floor will be assumed to be okay, and then we will start designing beams now from the first floor. And if the ground floor will require that we have beams, now we will have to design either slab beams for our foundations or ground beams that are tying our columns together. Yes. So we have 3 meter floor height. So I go back, I select my beam, I right click, and then I go to edit wall load. I select my wall load to be 200 mm thick Ndarugo block. Then the floor to floor height is 3 meters. If I have a beam that is 600 millimeter deep, therefore means I am remaining with 2.4 meters as the height. The wall thickness was also 0.2, this one we had set earlier. So you see now we have a dead load of 9.6 kilonewtons per meter. Now, if this wall has doors, windows, and all that, you can edit the openings from here.
But there is no need, yeah?
Yes, you go to edit openings. I just want to show you how it is done. Yes. Now, this is the full wall. We are assuming it has no openings. So, to add an opening, you come here to add. Then you see it has automatically added a window. So you can use the dimensions W, H, X, and Y to position this window correctly where it's supposed to be. But as you can observe, Y is 700. It is the height from the lowest level. So you can even raise it up. You can type here maybe 1000. Goes up. And then from the start to this point, probably it is 1500. So you can put distance from the x-axis as 1500. And then your window dimensions now, the width, assuming the width is 1200 and the height is 1500. So you see it has surpassed that. So assuming it's maybe 1000. You see now we have our window there. If it has a door, you can still add. You see now I have a second window, but this one I can say distance from the bottom level is is 0. And then distance from X, assuming it is 3 meters from X. Then the height is 2400 and the width is probably 900. You see now we have our door there. Yes, and so on and so forth. If you want to delete, you just click on 1 and then you press delete. Selected opening will be deleted. Do you want to continue? You press yes and then it deletes. So that is how you do openings. If you want to do openings in beams.
So basically, the effect of all that is reducing the round, eh?
Yes.
Yeah, because once you put the opening there, that means now the loading in kilonewton per meter is going to reduce.
Yes.
Okay.
Yeah. Or sometimes you might have a structure where you have a wall of 600 millimeters, and then on top of that, probably you have MDF boards or glass. Yes, so that is how you can do that opening.
Okay.
Yeah. So if you don't want to do the opening, there is no need of going there. So you just, after confirming that everything is okay, you press OK. And then it will have loaded your beam. Once it loads the beam, it becomes red in color, apart from the rest. So you can pick beam by beam like that while doing these loads. But assuming all beams are supporting the same height of wall using the same stone, how do you multiply this load that you've placed on this beam to all other beams? You come to that beam you've selected, you select it, you right click, then you copy wall load. Do not confuse this with copy manual loads. Copy manual loads is different. Here you use copy wall load and you just copy it. Once it's been copied, you go to the, because this is the first floor we are working with, you go to first floor, then you click beams. See now beams, automatically beams is normally closed like that. But once you double click, it opens up all these beams. So you can select and press the shift button and select one by one. Once you select like that, you can there are two buttons you can press. You can press control. Once you press control, you can select one by one. You see? Yes. And that means you will avoid the beams that you don't want to be loaded. If you press shift, assuming I click the first one, then I press shift, I click the last one, it selects all the beams in between. Just like select. Yeah. Then I right click inside my work. Then I use paste copied beam loads. Then I select that. Then we'll have wall load defined in the selected beams will be replaced by the wall load copied to the clipboard. Yes. Then it loads. It has now loaded all our walls. If you go to the 3D, you are able to see all our walls have been loaded like that. So we have been able to load our beams with walls. What about our slabs? Having done beams, we go back to our plan view. For slabs, you go to floor number 1, then you pick slabs, you double click, then you are seeing we only have 2 slabs. Then I hope you remember last time we said if they are solid slabs, you first of all come to set slab types automatically. It sets them from number 1 to 13, apply to all slabs in the model, then you press OK. Then it does that, press OK. And then you can right click still and go to slab table. Now, if your structure has ribbed beams, you will be working, has no ribbed beams, you will just use this slab table to load all slabs. But because our structure has one-way spanning slabs using these ribs, it means we will use ribbed slabs for designing of those ribs. So here we go to slab table, then it will list all solid slabs that you will have modeled in the structure here. Then from there, you can be able to see the height of our slabs is 200 millimeter thick. It has automatically calculated the self weight of those slabs. And then if you want to do an additional dead load, you can enter the value here. This tells you the type of structure you have, but you can just enter a value here. Assuming I want to do an additional load 1.5 kilonewtons per meter squared. I can still do 1.5. Then for my Q, this is the live load. I'm going to use 2. This is a commercial structure, sorry. So I will use 3. These I'll use 3. And because it's commercial, I'm also going to increase my dead load to 2. Because you never know the kind of loads that the shopkeepers and all those commercial people might apply on this structure. Then that is okay. So you go to close. If you do that, you will have loaded our slabs. To confirm whether your slabs are loaded, you can come here. This is slab number 13. You click on that slab, you right click, you go to properties. In properties, you can see the depth, you can see the concrete cover, and then you go to loads. This is where you are able to see whether your slabs have been loaded or not. You see now it has calculated the load, and then it has also added additional dead load. I've done this because tiling and then it has done a dead load. So if it comes raining, snow load, and all these other loads, you can do them here. Once you change this, you can click apply and close. Then it changes the properties if you have changed them. That is how we deal with slabs. These are solid slabs. Now for ribbed slabs, you come to ribbed slabs. You can right click, go to ribbed slab table. You see now I'm having many of them because they form bulk of my slabs in this structure. And then they're telling me that the width of my ribs is 150. This is the only one at 100, so let me change it to 150. They are 150 all through. The height is supposed to be 300. The height is 300 all through. And then I have a final screed of 70 millimeter on top from the 300. The size of the block is 400 millimeters. Then using all this data, it calculates the self weight of that slab. Then from there, you can even do an additional dead load, assuming I'm doing an additional dead load of 2. You can select all that, put 2, and then press enter. You can see, you can still do that. Yeah. So now I need to input my Q. This is the live load. This being a commercial structure, I'm still going to use 3. So you select everything like that, then you do 3, enter. For it to work, you have to select what you are seeing. Hope you realize, this is 0.3. Let me change that. My mouse is giving trouble. This is 3. So still go and that is that. So for concrete cover, you can do your concrete cover. But having defined all this, we have been able to define the main parameters of our slabs. You can still do a concrete cover of, let's say, 25 millimeters. Yeah. Don't know, my mouse is giving me trouble. Yeah. So we have finished loading our slabs. Then you go to close. That means we have been able to load our beams and our slabs. Now, after you have done that, I hope you're still following.
Yes. Columns now.
Yes. Now for columns, we do not load columns because these beams distribute the loading to the columns.
Okay.
Yes. So they automatically load the columns from the way we have
from slab to beam to column.
Yes. So for this, I have not finished with my slabs. I need to do something. Now, when you go to modeling, there is this thing called slab strip, but I can only
So
do, yes, slab strip. I want to open it. You see, I have this. Then the type of strip, it's an analytical strip, and I will explain all these strips. You have analytical, finite element strip, and manual strip. So for solid slabs, you need to use analytical strip. Like this solid slabs here, you use analytical strip. For ribbed slabs, you use finite element strip. So that is what we will be using when we are doing our slab strips. And then
okay.
at these limit status is where your strip is starting from. Is it at the this is the condition at the start and this is at the end. The first one denotes a slab that is continuing to the other side. This denotes that this slab is ending there or starting there, sorry. And this denotes that our slab is a cantilevered slab. At the end, the condition is also the same. It might mean that either the slab is continuing or the slab is ending there or it is a continuous slab. And you will see as we are going to use them right now. So, because it is an analytical strip and it is the start, I need to come here. This is the x direction. I have to do x first and then I do y. So I click outside and then see where these solid slabs are ending, it is continuous to the other side. So I have to change this. I have to use continuous. And then I click, I ensure it's vertical. If I want it to be vertical, I press down control, then I click there. It is telling me load cases and combinations are not defined. So I have to define load cases first. But you see, it has already put my reinforcement.
Mm,
Yes. Those, so I am putting slab strips in the x direction. And remember, it is analytical strip because it is continuous. And remember the end
mm,
condition. I start the strip while it is end. This is the center. And then I end this my solid strip when it is continuing. There is a slab continuing to the other side. Just like that. And then I'm done with the X. Now I go to the Y. I'm looking at the solid slabs first. For the Y, if I'm doing this,
mm,
this is end and this is end. Therefore, I have to use end to end. I have to use this. I do that. It still tells me that. But after doing that, it does my reinforcement. And then for this one, it is continuing inside. So we change that. Can start it here. Then I press Control for it to be straight. Okay, I have my reinforcement in all my solid slabs.
mm. So you are you are clicking the limit status first.
Yes, yes. You have to find out how am I starting my slab. It is a discontinuous end. How
Continuous, discontinuous.
yes.
Mm.
How
Now
am I
where are you
finishing
in
it? It is continuous.
in in all directions?
Yes.
Okay.
So that is for the X direction. Now you just
Mm-hmm.
click update and then you see now there is a warning we have been receiving here and we have been ignoring it. Let's read through. Load cases and combinations are not defined, and I will show you how to define them just right now. Dead and live combination factors for both load cases will be taken as 1.0 as default. A load combination set must be defined in order to use proper combination factors. So we need to go and set our load cases for us to be able to do this. Therefore, what we have done here is not right. When you'll be doing it, first of all, define the load cases before you do the slab strips. How do we define load cases? You go to analysis, then you go to building analysis. Then once you get here, you go to loading combinations, then loading generator. From there, you can look at all this, but for now, I want you to uncheck this notional loading. Just undo it and then press OK. It will do 3 load cases, three load combinations. Then load cases are 1, 2, 3, and 4. So you just press OK, then close. Therefore, we will have defined our load cases. So defining load cases was important before doing these slab strips. Now, since we have defined those load cases, let's do the slab strips for our ribbed beams. So you come to slab strip. Remember, these are ribbed, so they are finite elements. They are normally analyzed as finite element strips. So you come here, this is the x, let's start at the x, this is the end up to the end. So you do the end to the end, discontinuous to discontinuous. Do that, then you can press control, and then you do that. You see, it once you just see that red line, just know that it has already taken that into account. You might not see the reinforcement here because this is a ribbed. Having done this, we proceed to this one. This is the start, but when it gets here, it is continuous, so we change that. It starts, goes all the way, but when we get here, it becomes discontinuous. It has also drawn that line, so we are good to go. And you also do the same here. This is continuous to discontinuous. Though there is a mistake we have also committed, I'll still explain it. Well, it's not a mistake, we have committed. We have committed an error of omission. So you do the slab strip just like that. Before the interruption, we were doing the slab strip for these ribbed slabs. Then we said this is continuous and this is the end. Can do that. Put it. Press control and put it there. See, now it is not bringing what we want. So let's use this one, the internal one here. Yes, there it is. This is also end to end, discontinuous to discontinuous. Sorry. This step is very important because it helps in the design of slabs. Yes. So you do that, then we are finishing finally with this. So that is for X. Now you also do for Y. If I have that there, and also do this here, end to end. You press Control to make it straight. That one is also well taken care of.
So you do that in every slab?
Yes, you make sure every slab has been touched. That is the only way this is going to analyze your slab. So this is continuous to continuous. That. Let's control to make it straight. Okay, it has been input there. Now, I said there is a mistake or an error of omission or committed. Remember, this was supposed to be the staircase. Yes. So
they should not be continuous.
Yes. So at this point, it should not be continuous. But I'll show you how to model a staircase later on. For now, let's just assume it is a normal slab. So it is end straight. Now we proceed with this one. Press Ctrl to make it straight. If it selects the wrong thing, you escape and then you start again. So this is why, yes, Control.
It's like now you are considering two slabs.
Why two?
Because you see, like the Y, those are two slabs now that you have taken. I thought you are taking one by one.
No.
You can take from.
As long as you can take a number of slabs, it's still okay.
Oh, okay, yes, yeah, okay. Mm-hmm.
So yeah, so we have done that. We are remaining with this small portion here. Yeah, now we have been able to do slabs for all our slabs. Something that people normally forget when doing rib slabs that disturbs them is this type.
Oh, yeah, the one that you were explaining earlier.
Yes, you must change it to finite
Mm.
element. And then
Yes,
what we have also committed, which I had not checked, is this one.
the finite.
Yes, once you discover the finite element strip, you go to FE
Mm-hmm.
and then you decide the type of slab you're using. So it is this
Oh,
rib slab.
because the ones now that we are using for the solid.
Yes. Not sorry. Yeah, tell us because I was selecting that one. FE rib slab. All these are different. Like
Mm.
span band strip. So the best to use for our case is this.
Oh,
Rib slab. So whatever you have done, when you do it, you go to generally, you make it and then you select this.
okay.
Yes. But because of the interest of time, we will not do it. You have seen it is the process is still the same. After selecting this, you come and
Mm.
continue with this. But ensure this is FE strip and this is
Mm.
FE rib slab. Yeah, so that is how you draw slab strips
That is.
for your slabs. Now, from that, you have been able to load your slabs, you have loaded your beams, you have drawn slab strips, and before you did that, you defined load cases. So the next thing we are going to do is, because we have been able to model our flow fully, is to multiply this flow to other flows.
Mm-hmm.
Because when you observe this 3D, it is only one flow.
Mm.
So I want to have my all flows here. If there were 6, I want to see that here is a 3. What do? I go to building setout. I go to stories, operation stories. Remember, I had already inserted stories in the previous class, and then
Mm.
I went to edit. We also edited a few parameters. So now we are proceeding to generate story. Once I click
Mm-hmm.
generate story, you see it has by default selected story number 1.
Mm.
Yes, this is the source story, this is the target story. So I need to consider when I click on the source story, I can multiply this to any other story that I want. I can even multiply to the 6th story. But in this case, I want it from 2nd to 6th. So I select everything. And then number type to be generated, you also determine what you want to be generated. Because my floors are uniform, I also ensure all the boxes are ticked. And then I can go to, there is also a clause here. Replace existing columns, walls, and beams at the same insertion in target story. That one we can leave it blank because we have already copied all these things. So you press OK. Then it will tell you these and the previous processes will not be undone after this step. Do you want to continue? Yes.
You cannot change that now.
Well, there is a way of doing it. What you can do sometimes, if you have modeled and and generate them afresh and correct your error. So there is a way. It's just that if you don't know, you might have a difficult time. So this process is complete and then you press close. After that, if you open the 3D, you will be able to see your entire structure here. So this is the ground floor, first, second, third, fourth, fifth. And then, of course, it has a roof. But there is something we were mentioning. This structure is not like this. It has, the staircase has an extra floor. This topmost floor is supposed to be just for the staircase alone, not all these other elements.
So you have to delete the wall.
So you can go to story number 6. If it is not appearing here, you can select it from here. And then you can start deleting these things one by one.
So the story number 6. Oh, yes.
Yes, because our story number 6 only has the water tanks on top of it.
Then we are also going to affect the columns. Not there.
You see, this was the slab.
Where was this? The staircase was a solid.
Yes. So we're going to delete everything.
What I'm asking,
Yes.
Where was the staircase? You are not supposed to remove the one with the staircase.
The staircase was here.
That was saying, we were not supposed to remove the slab.
No, the reason why we have to remove it, the slab was ribbed. It was a ribbed slab, and we want to do a solid slab.
Oh, okay.
Yes. So you can delete all this. Though there is a way you can group all of them and delete at once, but I want you to first of all learn this manual.
Then,
yes.
We are also going to remove the columns.
Yes. As you are seeing, I'm deleting almost all of them. Yeah, so I think you can just proceed.
Yeah. Can we see the 3D? You see where it has removed? Yeah, it is clear. You can see some parts are not there now.
And you think my things are loaded because though I'm supposed to delete all these names. You can even delete them from
that is easier. Because you can, but you can remove what you don't want to remove.
Though there is a way you can delete all of them at once. But I wanted us to delete one by one so that you can see.
You can select several.
Yes.
Then you delete them.
Yes. Not only even selecting from here, you can delete from this side. If you want to delete all beams, or if you know their numbers. Yes. So I think let's just delete. We have time. It's not a hurry.
Okay.
Yes. So
Something I wanted to ask. When you are doing the beams, can you extend the beam, or you can only do another one?
Extend it.
You want to extend a beam, it was a certain size, and you want to increase the size.
Yes.
And then I get the length of the beam, and I saw that there was some difficulties on doing it.
Yes.
I was forced to remove the entire beam, then I do another one in order now to have it in the size that I want.
So if you want to lengthen, you can just draw a new beam.
Oh yes, that's what I'm saying.
Yes. So they will be labeled differently, but the way they will go operate.
Okay.
So you see, I'm almost finishing now. Just like this one. You see now it has deleted everything. So I can
But remember where we have the staircase? Oh yeah.
Yes. So I have done that one. I'm almost done.
Uko na TV karibu?
It is far. It is very far. Modeling, and then we go to now. Oh, sorry, you have observed I have deleted everything.
We
See
go
now
back to the 3D.
the way the 3D is appearing. Now I can come and do a slab here. And then of course I need to change these properties. I do 200. Close. Now you see I'm having the slab, and then if you look at the 3D, you see the slab is there. And then I can even change these walls, and all that. But what I wanted to do is load this slab now with water tanks. Now you right click, you select.
Have you loaded the slab, Lily?
Yes, we loaded the slab. Remember when we were looking at the first floor? Where is it? Let's go back.
No, I'm talking of the one for the staircase, the one that you have inserted right now.
No. That is what we are doing.
Oh, okay.
So you select that, you go to set slab types automatically. Okay. And then once it has done that, you can still right click, select and load properties. From here, you can go to code. You see now, this one we have not loaded. So I'm going to do an extra dead load of 1.5 for waterproofing and finishes. And then I'm going to do impost load of assuming 2 kilonewton per meter squared. But now you see we have water tanks. How do you get the load of water tanks? You take the height, you multiply by 10.
The height of what?
The water tank. And you will have loading by kilonewton per meter squared.
Weight of the water tank?
You take the height.
height of the water tank, you multiply by 10.
Yes, and that one you can derive.
But are you not going to consider the wind?
No. Now, when you do derivations,
Mm.
you realize that water has 1,000 kilograms per meter cubic, something per
Yes.
cubic.
Okay. So
when
you
you
just
do all that math, you will realize that it will
this
it
times
will
one.
become height times 10. That is the loading of water.
Okay.
So now there is something we call quasi-permanent.
Sorry?
Quasi-permanent. And I think you can read the Eurocode on the same. When we are designing for water, we can consider it to be partially permanent load, not a live load. So that means we are going to, if the height is 2 meters, that means we have a load of 20 kilonewtons per meter squared. Therefore, I need to add here to get 21.5 kilonewton per meter.
Yes, the end of the now.
Yes, on the dead load. If I do the live load, remember the factor for the live load is higher. So it is going to give me a more loading. But because it is quasi-permanent, it means I need to use it as a dead load. Then I press update and then I go to click. Then I still observe my 3D, still as good as it looks. Now,
is it covered under the top?
Sorry?
Oh, can I see there? Is it covered under the top?
No, you cannot see the tank.
No, the tank. The slab, it is there.
Yes, the slab. It's just that these beams have walls. So, yes, those beams they're carrying some walls. And you see, this wall is not there. Edit wall load, go to that block.
But engineer, there is something that I wanted to ask.
Yes.
Can you avoid putting the walls? You consider the weight of the wall on your beams.
On my beams. Now, when I do that, it is modeling this to show me how my walls will be sitting on the beams. So it does not mean that my walls are the ones that are carrying my floors. No.
What I'm saying, instead of doing the walls,
yes,
you just factor a load that will be resting on the beams.
Yes.
So you can do that.
Now let's look at that.
In such a case, we say you are now considering the wall when you work only on the beams.
That one you can do because, but it is going to give you a low effective work.
Because you have to calculate.
You can select, yes, you have to calculate exactly. You can select beam, right click, and then go to edit. Now you see we were editing wall load.
Empty beam load.
Yes. Now this one you have to, it has to be a manual load. Copy manual loads, beam, paste.
It will be a lot of work.
Yes, it is going to give you select and load properties. It is just going to give you a lot of work.
It's better to do walls than beams.
To do beams and load them with walls.
Yes, beams you don't need walls.
Yeah. And if your loading is too much, you can factor in. Yeah. So we have finished our model. Now the next thing is to run an analysis. Yes. So from loading, you can go to review. Though in review we don't do much. You can just run a building model check. Then you start. Then it tells you number of errors is 1. Let's look for those errors. Which is the error? It's here. Axis 17 and 1 are overlapping. Axis, the grid lines. Yes, so that is not really an error that can affect anything. It's just that grid lines are overlapping. So you go to close. Therefore, our model is okay. Now you proceed to analysis. You come to building analysis. Then this is where you now do things. Now remember, we came here, we did load combinations. We came up with our load cases. So we are going to still leave them like that. Just say, okay, they are going to remain the same. Then you come to edit materials. Here you are going to edit the type of steel to use, the type of bars you want to use there, and all that. But we are not going to look at that today. We will look at that in our next class. We will analyze, look at the analysis results, and design now the beams, columns, and all elements. Yes, so for today, just work on the slabs. We have loaded slabs and generated
beams.
Yes, and beams and generated these two other stories. Yeah, so work on that so that next time now we